Hello everyone, welcome to the CNCDP Sneak Peek. My name is Liu Li. I'm the training instructor from the EPI company. CNCDP is the Certified Network Cable Design Professional Training. The data cabling, or commonly called cabling system, is the infrastructure to support the IT networks and the devices. In this training, we will talk about how to design and build a cabling system for the commercial building and a data center environment. In the first day, we will start with the logistics, which will talk about the high-level deliverables of the class, the expectations and the examination details, and break time, lunch time, these kind of things. Then we will have a few minutes for the attendees to share their background, their job experience, expectation to the training as well. Then we will start with the introduction. So introduction, we'll talk about the brief history, standards, basic components, give you a quick recap what is a cabling system. Then we will talk about the horizontal cable. Horizontal cable is the cable segment between the wire room to the end user outlets. And then the administration is the patching area. So where do we put them? How do we do it more effectively? Because when you do the patching more effectively, basically you are improving the operation efficiency, right? For the commercial environment, and also we would also talk about the data center environment. On the second day, we will talk about the building backbones. Now, the building backbones in a commercial building is usually the cable connectivity between different floors, the wire room on different floors. But you can also have the very big building which have a large area on the horizontal. So the building backbone could be also connected different areas horizontally, not only vertically. Then we will go to the building backbone for data center. Now the building backbone for data center is mainly, number one, go to different data center halls, right? If you have a massive data center, very big building, you can also using the backbone cable to connect to different layer of the switches, like from aggregation to the core, then you connect them together. It's also called a backbone. Architecture consideration is talking about the physical environment, like the cable trunking, cable pathway, fire-rated partition, the sizing of the room, something like that. Now the campus or outdoor backbone is when you have multiple buildings, multiple data center. You need to connect them together. So we'll talk about the types and of the backbone outdoor and how do they to be installed. Then we'll also talk about the site inspection. Because cabling is a kind of project service. So you buy the product and then you need the installer to install them. So the overall performance, the cabling performance, will be determined by the cabling products and also the workmanship level. So we'll talk about some of the common issues and when you do the site inspection and checking, so what are the notes that we should take attention, and also the different testing model. Now in the classroom schedule, normally the first day is 9 to 5, second day is 9 to say 4 o'clock, then from 4 o'clock we will take the exam right away, 4 to 5 around 1 hour. But if this is in a virtual class, then the exam could be arranging at your own pace, or could be different timing or in the same day. Module 1, Introduction to the Structured Cabling System. In the Module 1, we will go back to the history of the SCS. We will talk about the basic working principle for copper and fiber cables, the types of cables, copper and fiber, single and multi-mode fibers, and what is the step or graded refractive index for a multi-mode fiber. The difference, consideration, and the requirements between the commercial building and data center cabling. The development, process, and the history of the cabling standards, the role and technical content of a standard, and also the most important cabling standard is called TIA 568. Other related common cabling standards, and also the new usage of a cabling to support the smart building. The cabling system has been used to support the IT devices and the IT network for commercial building and data center for a long time. But nowadays there are more new usage, say BMS, the building management system, smoke sensor, humidity sensor, or even PoE, right, power over Ethernet, lighting, access point, CCTV, so for the energy management system, etc., etc. Also the public address, PA system. So there are a lot of new applications that can also supported by the cabling system. Here are some slides that taken out from the training, so have a few about the training. Say the brief history. So way back in 1960s, 80s, actually at that time there were only a few big companies, computer companies, and at that time the PC is not available yet. Because the PC actually, the first Apple PC and IBM PC came out in 70 and 80. So at that time, the wiring is only between, the computer room and the small areas. We heard a lot, single mode, multi-mode fiber, right? So actually, what is the mode? Why we call it single mode or multi-mode? Now the mode is actually the light path. Means that the single mode is single light path, and multi-mode is multiple light paths. Easy. And the single mode fiber is using a very small core diameter and usually with a laser transmitter. So laser transmitter will only give you one light path all the way from point A to point B. For the multi-mode fiber, usually we're using an LED light source or light transmitter, and LED light transmitter, they will come out with hundreds or even thousands of light rays, so they will come out with a diffusion too, so a large amount of lighting going different places. And then the multi-mode is a bigger diameter to allow many different light paths to go through the fiber. So this is the multi-mode, and because of the many light paths go through the fiber, and the way they go through the fiber is by the reflection of the light. So means that actually they travel long distance. You see that here? You see that here? They go long distance and causing higher attenuation. So that's why single mode fiber is usually for the long distance, and multi-mode is used for a short distance, say inside the commercial building or data center. The commercial and data center cabling, what is the differences? Now the commercial cabling or commercial wiring is mainly for the end user, means that the cable are connected from the wire room to the end user locations. They are not mission critical, because if your cables in the office are not working, you can sit to next chair to find the connectivity again. So there's not critical requirement that for the resilience. So if this cable die, your desktop, you must have the backup cable, generally speaking. But when you come to the data center, the cabling are mainly for the servers, network, and storage. So they are supporting the business. So say for example, if you're running a data center for a stock market, if the data center, the connectivity have problems, so the network cannot be operated, then of course that one will cause you a lot of financial loss. So this has become a mission critical thing that the cabling need to have resilient or high availability design. Module 2, the horizontal and administration design for the commercial building. We'll talk about the 568 standard diagram. So inside the standard, there are different functional elements or the components. And when we go to design the cabling layouts for a commercial building, we can do it either counting the number of work areas, means that we divide the floor plan into a small unit area, and then put there how many cables per unit area. Or really we go to count the well-defined or already defined user locations. So we count 1, 2, 3, 4, and then put the cable exactly as how many user locations are there. There is something called zone wiring. Zone wiring, it's distribution method when we go into a big area. So instead of a point to point, so we go to a particular zone, we got a zone, and then the cabling will go to a particular area, and then from there we fan out the cabling to the end user location. So we got a zone distribution. And we also define and explain more detail what is a administration point. There's two ways to do that. We call interconnect and cross connect. So what are they? And we also talks about, the different type of the patch panel, show you, the shape and how do we use it. And after the, we have the design first. We previously talked about, normally we will do a high level design, we call schematic design, talks about the functional component, the requirement, then we convert into the physical layout. Of course, in the last part, we need to calculate the material for ordering the material. This one shows how we design with the number of work areas. So usually it's used for a high level, preliminary budget design in the early days, or you have a very high density office. So we just put, how many work area. Work area means that 10 meters square, defining area. And when you put more work areas, then of course, in the future, you can have more flexibility. No matter you move around relocation, then we can always have the cable. No matter the people add in to move in, then of course the cable is there. So commonly is design is each work area will have 2 to 4 cables. Another scenario is mainly for the user locations when they're clearly defined. You don't want to have flexibility. It will not change and cost sensitive projects. Of course, this one will give you less flexible, but you save the money, okay? So in this case, for example, we can have the floor plan that really go into count the number of cables. Module 3, the horizontal and administration design for the data center environment. We will start with the TIA 942 standard. This is a data center cabling standard. So we'll understand what is it all about, like the setup of the data center, because inside the standard they will talk about different configuration, basic, reduced, typical, and we will go into review the traditional 3-layer switches, network design, and spine and leaf, because the cabling will attach to the network, right? So so we need to understand what is the network design before we can come up with the associated cabling design. Then we'll talk about the termination hardware, which is the different type of the patch panel, administration design, similar to the commercial building. Then we will, when we have the information of the network design, then we will create the cabling design, associated cabling design. And based on the TI 942, there are 4 rating level or rated. So these are the level of the resilience to make the data center and data center cable more safe. So based on the target rating level, then the cabling will also require different level of the resilient and redundancy components. Then after we have the information available or put together, then we'll create a schematic high-level design. We'll show you the example for top of rack and of road, and then we convert them into the patch panel or the physical rack layout and calculate the material list approach. Now this one is the standard diagram from 942. We got 942 usually. So data cabling standard. So in here we talks about different rating, and the different rating they have more cable redundancy. So this is a summary table. This is the actual requirements for the cabling redundancy based on the different rating level. If you need more information, go into the real document. Termination of the cables. Now in a commercial environment, the end user are sitting in different desk locations. So that's why all the cables are at different lengths. And the installer need to install the cable one by one and terminate each cable at our outlet and the patch panel on site one by one. But in a data center environment, the cabling are mainly between the racks to racks. Say from this rack, you have 24 cable or 40 cable, almost exactly the same length go to another rack. So that's why there's an option that you can get the preterm copper and fiber cable from the manufacturer. So they install, test at the factory. When they ship to the site, then you can plug there right away and save your time. Now this is the fiber patch panel. So different type, different number, different connectors. Module 4 is the backbone cable for the commercial building environment. Now backbone cable, we will show you the diagram, so you know how to define a backbone, and the basic recommendation, so how many pairs, how many core for the copper and fiber backbone when you come to do the design. And then say if you have multi-floors, then we'll put all the different floors, all the backbone into a summary table, because we need to calculate that. And we'll also talk about the what are the recognized or recommended cables from the technical standards, and patch panels, and how long they can support, the maximum distance. And again, we create a schematic and then convert to the physical layout. So the backbone in a commercial building basically is the cabling segment to connect different floors. Or again, if you have a big building, of course you can connect from zone A to zone B. We still call them a backbone. This one is for the fiber. Previous one is for the copper. Now we also do the same thing for the data center. So in the data center, we will go back to recap 942 standard, which will define the topology, the requirements and recognized cable. Again, the different type of the network structure, the distance, and when we come to different rating or rated level, then there will be a definition or requirements that we define the resilience to put in more backbone cable, horizontal cable, something like that. Now again, we will create a schematic high level, the functional component, the distance, the different section, distribution of the patch panel. Then we'll convert them into a physical rack layout, and then we'll explain when we do the backbone the different type of termination, like the field termination, fusion type, preterm. Now this is the fusion splicing. which is the most common termination method for the fiber backbone cable for today. So basically, it's you have the fiber backbone, fiber cable, then you open up the jacket, and then you put into a splicing machine. Splicing machine basically is a high temperature, like oven, like microwave oven, something like that. So you put the fiber cable, then you have a higher temperature, they melt them together. So this one is slightly higher attenuation than the traditional field termination, but this is a very common one. For the backbone, we can also have the preterm version for both copper and fiber. Module 6, we'll talk about the architectural considerations for cabling design and installation. In the architectural considerations, the standard is called TIA 569. The full name is Cable Pathway and Space Standard. So it defines what are the common requirements for the room. For the room means that the wide room, like the architecture, the sizing, the mounting, the plywood for the patch panel, trunking, air, electrical, power plug, something like that. Then we will define into different rooms. So some are the major distribution, small or common room. There are different type of rooms, and we will also explain what is the entrance room. Entrance room, or that demarcation, is the area that the telecom coming into the building. Ceiling, pathway, floor pathway, the cable basket, trays, ladder, conduit that to support the cable routing. Inner duct, sleeve, slot, is a passing through the different floor, different area, the openings on the floor, etc. How to calculate the pathway size based on how many cables? So there are some recommendations. And what is the cable run best practice? Say, for example, to avoid conflict with the airflow, something like that. And we also have the cable management. So how to do the cable management, especially for the AIM nowadays, we got AIM, automatic infrastructure management. So it is a combination of software plus the hardware to auto detect the cable patching and to do the record, create a database, something like that. Then we'll talk about the grounding, bonding, distance from the power cable, fire stopping material, types, barriers, and fire jacket, fire safe cable, etc. So the architecture standard, consideration standard is called 569. Again, they will define different pathway, and the rooms are called distribution room, common, entrance, access, telecom area. And this is a typical layout, show you where to put what facility, like the power, the cooling, the cable racks, pathway, etc. Module 7, campus and outdoor backbone. Module 7 is talking about outdoor, basically campus outdoor installation. So we have an aerial, hanging cable, direct buried or underground in conduit, based on your environment, your condition, the provision, what kind of the facility that you can have. So we talk about the outdoor cable installation planning. So what are the information you need to have before you can go into do the installation? When you go into outdoor environments, there could be the risk of lightning, so surge protectors, grounding, we will create a high-level schematic diagram, and then again convert them into the physical layout. This diagram shows you how the outdoor cable commonly installed. So we have aerial cable hanging on the poles. Direct bury means that the cable need to be able to withstand a very harsh environment by directly put into the soils. And we have the underground in conduit, means that there's a conduits or the tunnels already available, so you just slide in the outdoor cable. Now this one is the indoor or outdoor fiber cable to show you the structure, right? You see this is armored, the jackets will help to protect the fiber from damage. So, or you can have indoor, outdoor means that they can either go to outside environment or all the way go into the building vertical riser. And then this one will have a fire rated jacket, because if the cable going through the building, that could be very dangerous. In case of fire, you can burn all the way through different floors. So different type. Module 8, Site Inspection and Testing. We will share with you some of the visual site inspection nooks, best practice, and common issues of the installations. We will go back to the copper testing standard, which define different testing configurations, and then we will go to the fiber side. So we'll talk about different types of the fiber connectors and also the fiber testing standards. When we come to the fiber testing, there are two tiers of the certification. The tier 1 is the attenuation, or nowadays we call it insertion loss test. Level 2 is more complex, using the OTDR tester. So these are the basic concept. Then we'll go into it by talking about, so what is the end-to-end definition of a fiber link? We'll explain the testing steps of a fiber, and then before we go into the test, we need to do the inspection and cleaning on the fiber connectors to make sure that they are in good condition, and then we will calibrate the test set, prepare for the testing. And the 3 ways to do that: we will set up the man tray. Man tray is a small tool to set up the fiber in a consistent testing environment. Then we will look into how the fiber loss budget is being calculated. So we will have an estimation before we do the test, and then we estimate how much is the fiber loss. Then we compare to the testing result to ensure that the fiber test is correct. And we will also introduce band insensitive fiber called G.657. This is a very good product when you come, especially when you come into a data center, because in data center there are so many fiber cables, so and they are housed in a very tight space that will affecting the attenuation. So band insensitive, that will help to reduce the problem a lot. Then we will talk about what is OTDR, we previously mentioned. So what is the basic principle, how to read the readings. There are some of the common issues with the copper cable installations. So you can see how the cables are being damaged. For example, using a cable tie, stapler, or too much pulling force, or pressed, maybe the people step on it, or the cable are being twisted. On the fiber side, the fiber connector, before they go into the installation, we need to do the inspection to ensure the fiber connector are in good condition. So these are the common issues, say the too much oil, the grease on it, the dirt or cracked fiber. So if the connector are serious damage, then we need to replace it. Of course, if this is a grease or dirt on it, and then we can clean it, then we will keep the connector to be used. I think our information is good enough for you to get a feel about the training. So if you need more information, you're welcome to visit the EPI website, which is the epi-ap.com/CNCDP. So we have the brochure and the syllabus information you can download to understand more about training. Thank you for your time. If you still have questions, please feel free to send us email, and you are very welcome to follow us on the social medias so to receive our updates. So bye for now. Thank you.